So, um, Greetings, sir. This is Apurv Goyal from Department of Computer Engineering and faculty number 19COB038, presenting the paper term on topic web mining. So let's get started. So research papers that I have used for this particular paper term presentation are research issues in web mining and impact of PageRank and citation count algorithm for digital libraries. So why I have used two research paper is that I actually want to present as to how PageRank and citation count algorithms are used to actually improve the search results, and how are they actually solving the research issues that are present in web mining these days, and how they will be actually solving that in future ahead as they are evolving over time. So a brief introduction on what we are going to see today is what is web mining, classification of web mining, pros and cons for each classification, roles of ranking algorithms, and distinguishing between the PageRank and citation count algorithm, which is used in digital library search engines. We'll see more about what these terms actually mean. So getting into what web mining is. So giving a very simple example of web mining is that we are actually extracting the valuable information that are present on the web. So we have the huge chunk of information on the web today, and based on our needs, we actually scrape them or mine them in the terms of data mining techniques. So basically, let's take an example as to how it is actually used to solve the uh, problems, such as the one that we already have discussed in one of our lectures, right? So where we saw the example of how a person goes into a web store and buy a beer along with the baby's product, right? So this is something that is kind of non-trivial. One can't assume that a person who is coming to buy products for a baby will also buy a beer, right? So, but this is something that was observed based on the data analysis that was done. Web mining is one of the applications of data mining, and these data mining techniques involve classification, clustering, association rules such as a priori techniques and whatnot. So this is how we actually use this information that we have with us to generate useful results. In some cases, we take it from website where we call it as web mining. In other cases, we take it from raw data that we have generated from our particular sources. Now let's get into what challenges are faced into web mining. So data is too much unstructured, and with increasing complexity, it becomes difficult to churn it out and find what exactly we need. So there are three classifications that have been done to tell what type of data mining techniques, what kind of mining, web mining are there. So these are WCM, web content mining, WSM, web structured mining, and WUM is web usage mining, which we will be seeing in the later part of this. So all these classifications involves four-step process. First is we find the source where the data is coming from. Then we select the data and reprocess it. Reprocessing means that we clean the data to reduce the noisy data from it. And then we do generalization. Generalization means to make it more generic, to make it more oriented towards what we want to do, with, basically what we want to do with it, and then analyze that data to get the useful results out of it. So yeah, next is classification of web mining. So web mining is classification I have already informed, and let's see what is web content mining classification. So web content mining is basically classified into web page content mining and search result mining. So web page content mining basically means that we extract the data from the web pages such as HTML, text, multimedia, images, videos, data, etc. Search result mining is basically that we actually capture the search results and use it for our own purpose, whatever we are getting. So what are the approaches that are being used for web content mining? So basically there are two types of approaches. Let's understand both of these approaches. So as we know, web content mining is basically scraping the content that is present on the web. Now, agent-based approach basically involves three types of agents. So let's understand what is agent-based approach. Here we use a tool or some kind of agent that is helping us get the data. Now, this can be in three possible ways. One is intelligent search agents. So intelligent search agents mean that we actually have some bot set up already, which is automatically scraping data, and it knows what kind of data it needs to extract and where it will get it, right? So this is intelligent search agents. Now let's come to information filtering agents. So these agents are basically getting all the information. They are fed with all the information. The only method is that they just filter out the data from it. So all the content is fed to them. Now, personalized web agents, these are used in, you can think of is improving user profiles. So just take an example that Google is using your web searches history, okay, to improve your results whenever you are getting it next time. So suppose today you are searching more about uh, like computer applications, right? So whenever you search it again next time, you will see more improved results. You will see results that are more related to what you want to search, right? This is how they improve the search results based on your browser history. And we will come to later part of this, that how it is a pro and how it is a con. So let's come to the other approach meanwhile, that is database approach. So database approach actually means that we gather all the data in a database, index that data, and categorize is it based on different categories, and then we implement normal search queries that we implement in a database to fetch the data that we want to. Now, let's get into classification of web mining. So as we have already seen here, web content mining, let's talk about what are the challenges, right? So challenges that are faced in web content mining is concentrated information extraction, that we are not able to get the concentrated information, that streamline the information that we want to, right? Because of uh, like because of the huge unstructured data. Then segregating noisy data and online extraction from online sources. So you see websites like Stack Overflow. Today you search for a question, you will see, suppose you search for how to write console.1 in JavaScript. You may see a lot of threads on Stack Overflow, and each every person has a different opinion. Every person has a different way of writing it, and every person has a different way of explaining it. How can you extract those opinions from online sources, right? It depends on how well you implement your algorithms, right? So how well you are able to search, how well you are able to scrape all that Stack Overflow threads and understand the opinions based on the what do you say, sentiments, right? So what that person is trying to convey from their particular answer, right? So it can be controversial in some cases, it can be direct in some cases, and that is something that is a challenge that is yet to be solved, and people are working on it already. So the next thing is web usage mining, which is the second classification of web mining. So web usage mining is again of two types. It is done in two ways: general access tracking and customized usage tracking. So general access tracking basically means, so let's talk about web usage more. So basically, web usage means that we are actually using web server logs. So web server logs means that every website leaves some is logging its data, right? So whenever you are, suppose, entering facebook.com, so whenever you try to access your personal account, right, so that data is actually stored. So it just stores the timestamp that when you try to access that data, how many times you have tried to access facebook.com for a whole day, for a whole month, week, year, or whatever. Agent log are basically what kind of operating system are you using, what kind of network settings do you have, so that it helps to determine how well your application is performing in uh, 3G or maybe 4G data, right? Error log basically means that whenever some error is occurring while you are performing some action on the web page, so that is also logged. And the next is referral logs, basically how much your website is being redirected from other platforms. So this is basically the referral log. All these logs are basically used in what we call as general access tracking, where we compile these server logs, we compile the application server logs. So let's understand difference between web server logs, application server logs. Web server logs are basically more about the web interface that we are using. Application server logs are more towards the backend side. That is how the backend is working. So we use so these are scraped from the internet for a particular website to understand how well the website is performing, right? And this is what we call general access tracking, because there's no such personalized way that we are focusing on. But when we go on to customized usage tracking that we see over here, so it uses usage profiles, right? So here we are actually trying to fetch the profile data. So suppose I'm trying to fetch behavior of your account. I'm not looking into web server logs of all the accounts. I'm looking into web server logs of your account. I'm trying to understand what pattern are you following in, like what time you log in mostly, what kind of things you search immediately, what kind of post you want to see in that particular time. So these are all the things that are customized usage tracking. Now, what is the process? What is the process of web usage mining? So process is basically that we first pre-process the data again, the first process that we always do. Then we discover the pattern. So a pattern is discovered. So let's understand it with an example that how Facebook actually recommends you, your post, right? So basically, whenever you made your account on Facebook for the first time, you liked some post, you commented on some posts, you shared some posts. So that data was logged. Now that log data was used by Facebook's algorithms, and it was pre-processed to understand the pattern, right? So what kind of post you mostly see, what kind of post you mostly like, what kind of post you mostly comment on, and what kind of post you mostly share. And this pattern discovery is next utilized to analyze your data. And this again comes with a challenge that it becomes difficult in web research mining to identify the session, because now most of the times these sessions are encrypted, right? And caching of data is actually making it difficult for web usage to get the web usage, because caching will remain to your local server, and what it won't get stored in your web server logs. And then for the dynamic pages that we are getting from the frameworks such as React, Next.js, etc., so they are actually making problem for web usage mining, because every other time your page is getting updated on a component level basis, and it becomes difficult to track the track the whole page at once, because each component is getting updated at some particular time, which is not actually the updation of whole page at once. So since we have already talked about web usage mining and web content mining, let's get on to web structure mining, because this is how we will actually reach to page rank algorithms. Because web structure mining deals with the hyperlink and document structure. So whenever you Google search something and Google pops up with some responses, with some search results, then in there you're actually trying to get some hyperlink. Okay, you get some hyperlink to some particular page, you go to that page, you do whatever you want to do. Now hyperlinks are basically of two types: intra document, inter document. So intra document means for a particular web page you might have different pages embedded in that web page. For example, that you go on to facebook.com, you have profile, you have groups, you have friends, different sections, right? So these are intra document, basically intra document hyperlinks that take you to inside that particular page. And once you go to inter document, so inter document means that suppose you click on a link on facebook.com and it redirects you to twitter.com. So basically these are inter document hyperlinks. And we'll see like how these how these are structured in web mining. And the other thing is document structure that we call as DOM in JavaScript. So where it basically considers each node of a tree as DOM, basically a document. And these documents are basically connected with basically with edges. These edges are the hyperlinks that are connecting these documents. So WSM uses graph theory to analyze node and connection structure of a website. So graph theory is basically implemented in WSM, which is web structure mining, where the nodes are your pages and edges are the hyperlinks connecting those pages. So it is implemented. So web structure mining is implemented on digital library. Now, what is a digital library and where it came from? So digital library is basically collection of all the resources at one place. So it had been so if you have seen, you search for a research paper, now you get those research paper of examples from search results. But you see some particular website like researchgate and some other places where you actually get a set of research papers. They are dedicated for that particular thing. These are what we call digital library, which actually gather this data from all around the websites and provide it to you by indexing them, cataloging them, and kind of categorizing them based so that it becomes easier to search something. So it shouldn't be like you search for a web, you search for a research paper today, and you get images and some videos or maybe something, because this is not relevant, right? You need a document to read. So basically, this is what we call digital library, right? Which are integrating this data at one place. Now, challenges with WSM are reducing irrelevant search results and indexing information on web. So whenever you are trying to structure your web pages, right, and try to make a graph out of it, so it is important that you remove the irrelevant search results. So whenever you are trying to access Google search, right, so you don't want irrelevant search results. And indexing is important on web because indexing actually helps you get the data in O1 time. So this is also one thing that is a challenge in web structure mining, and these all are solved with what we call as the paging algorithms. So before we get on to that, this is the architecture of digital library search engine, which is very simple. So your website is crawled by a job that is running in the background always. So this crawl actually get the data from the web, convert it into text files, and these text files are then forwarded to a text extractor, which converts it into a document. This document is passed to a central database, which actually where it is actually read and indexed. So basically, this is indexed based on keywords or important terms present in it, so that whenever you search for them on the web browser, whenever database search is generated for this, so you basically get the data in O1 time because it is all actually indexed. So suppose you search from what is computer application, so basically that indexing will search for computer application term and give you results which are actually mapped to that particular key. um, that is right. So let's go ahead and see what is PageRank. So used by the famous search engine Google, it ranks a website based on number of outbound links. So let us understand outbound links. Outbound links are basically the links that are leading you from one page to another. And the more number of outbound links you have to a particular page, the more is it is ranked on top, and the more it is optimized for the search engine optimization, the more it is ranked at the top. So PageRank algorithm is not limited. It actually focuses on quality and quantity of page. So basically, quality means how like what is the quality of your website and the content. And quantity basically means the number of outbound links that are taking you to a particular page from other websites. So basically, it helps reducing the irrelevant search results. Now, its algorithm is pretty much straightforward, that you have a damping factor that is between 0 and 1, which was initially set to 0.85, but it doesn't affect much on the page rank because page rank basically works on PRT1 by CT1 up to N. So basically, if you have N pages that are leading you to page A, so suppose T1 page, T2 page up to Tn are leading you to page A in total, then page rank of page T1 divided by the number of outbound links going to your page T1 gives you basically citations to the page T1, gives you one particular page rank, and adding them all along for the different pages that are taking you to page A, and multiplying it with B, and then adding 1 minus B to 1 minus damping factor to it will give you the page rank of the page A. And citation count is just a subset of paging algorithm where you are actually just counting the number of backlinks. You are not, worried about the, what do you say, quality of web page, right? So this was the basic algorithm that was implemented very first time, and basically Brin and Page, who are the co-founders of Google, they actually used it to work upon it and bring the paging algorithm out of it. So this is the basic algorithm that is still used in a lot of search engines like DuckDuckGo and whatnot. And as it suggests, higher the number of citations, higher is the chance to get it marked as more important. But now we have to understand the comparison study between these two algorithms, which was the main focus of understanding all along what web mining is, classification of web mining, and how all these paging algorithms are solving that thing. So main technique that is used in paging and citation count is WSM already. but where PageRank is computes the score at result time while giving you the results. Citation count does it in the backend already and just give you the result. It doesn't care about what new content have been generated at that particular point of time. And both of these work on backlinks, though complexity of PageRank is O log n and citation count is ON. So obviously PageRank is more faster. It is relevant as compared to citation count because it is taking to check the quality of the page as well. And obviously, so because of this, the quality of results that we get on median as compared to citation count that are low. And limitation of PageRank is that results come at time of indexing, not the query time, which actually takes time. So when you are actually searching for results, it is basically giving the index result, right? So it is not that you are searching for a query and it is giving a result at the same time. So while the citation count treats all the citations equally, so if you have 10 citations for your page A, it will immediately give you the result if there's no such page which has 10 citations to your page and it is relevant to the search query that is made. So yeah, this is the basic comparison study between these algorithms. And as we come to the conclusion part, we understand that the usual search engine usually results in large number of web pages in response to users' query. And since page ranking citation count are already solving biggest challenges of WSM, it is also important to notice that privacy is a matter of concern these days. And as we have seen, DuckDuckGo search engine is one of the fastest growing search engine. Though it is the 10th most popular search engine today, accounting for around 2% of the searches that are made from DuckDuckGo. But it is gaining popularity. Why? Because it is giving you results without storing your data. DuckDuckGo actually says that we don't store your data. We are concerned about privacy, and that is why we actually give you results which are anonymous. So this is not similar to what Google search does. Google search use your data and give you the results based on your personalized experience, which is good, which is not illegal. But for some people, it is most of the people, the privacy is more important rather than giving the right data. And if that can be achieved without giving you the privacy with storing your data and using some techniques that can do it, give a workaround, what can be as better than that? So this is something that can be that is which has a rapid growth and evolution to say that algorithms are designed in a way to keep your privacy intact. And as a future guidance, web mining will require more sophisticated algorithms that solve the problem of WCM, WSM, and WUM respectively. So yeah, this was all about what I had for these research papers that I had read, and I really appreciate that we got to work on this, and I actually learned a lot with this. So yeah, I hope that you all understand it, and maybe it was quite clear that how we know more about web mining and its techniques and what are the challenges that are faced over there. So yeah. Thanks a lot, everyone, and thanks a lot, sir, for giving this opportunity to me. Thank you.